So 95% of all the railways in North America are running on right-of-ways that were built before 1890. So before 1890, you didn't have bulldozers, you didn't have earth movers, you didn't have trucks, you didn't have anything like that. So we drove the last spike to join Halifax to Vancouver in November of 1885. The entire thing was built with steam. You had steam shovels that were railway mounted. You had steam cranes. You had steam pile drivers. You had little steam saddle tank locomotives like this because you didn't have dump trucks. So when you wanted to move spoil or you wanted to move material, what you did was you bought a little 040 tank locomotive. The contractor, Pickett Construction, that got the contract to build the railway line between Guelph and Goderich, purchased 4 of these little engines, along with about 30 dump cars. So what they would do, if you drive across a railway level crossing, and you look down, and there might be a little valley there, but the rails are up nice and level, and they're up perched up on a nice symmetrical hill. Likewise, if you're driving through a railway underpass, and you look down before you go under the railway underpass, and it's a nice symmetrical hill all the way down to the left and to the right. So how they did that was when you came to a little valley, they'd build a stick trestle out of cheapest timber they could find laying around. They'd put 36-inch gauge track panel, a lot lighter gauge than that, only something like about 30 pounds to the yard rail. In panels, they'd set it up on top of the stick trestle. They'd bring in a railway mounted steam shovel, and if you parked out at the back out there, you saw that Browning railway crane. That model was available as a crane, or as a steam shovel, or as a pile driving outfit. All the same engine, same horsepower, same boiler, same undercarriage. You just cut the different fittings on it. So they'd bring in a mainline steam shovel, put a spur line into a borrow pit, and load 6 or 8 cars, dump cars, and then this little locomotive would back down the tracks over this stick trestle and dump the spoil in and dump the fill in. And they'd work their way up across the whole valley, and then they'd pull up the track panels and lay down the regular rail and carry on down the line. And that's how all the railways in North America were built, with little construction locomotives like this. And the main idea about having only 4 wheels is so that the entire weight of the engine is on those 4 wheels for traction. So this little locomotive, built in 1909, has a tractive effort of 5,250 pounds. It will pull, and when you convert that on level track with the lowest resistance of the track, they rate the track in pounds of resistance per ton. So on a straight track, nice and level, the gauge well set, you'll have a friction of maybe 1 or 2 pounds per ton. And as you start going into curves and all that, it can rise up to 20 pounds per ton. Even a real steep curve going up the hill as high as 50 pounds per ton that you're carrying. So this little locomotive on the level will pull 175 tons. And going up a 5% grade, it will pull on 20-pound pound of friction per ton rail, which is sort of mediocre, not the worst, it'll still pull 29 tons of load behind it. So these were used not only for the construction industry, for the railways, they were also used in the lumber industry, because you could lay these things and you could go up as high as a 10% grade with these little locomotives. And make steep curves and all the rest of it, and pull the rail out and lay it down somewhere else as you log that area out. And anyways, this company, they built, Vulcan, built over 5,000 locomotives in their operating history. And this particular locomotive was built in 1909, sold to a contractor in Illinois. And that contractor ordered 2 of these locomotives. And it was a big earth-filled dam that they used it on. And I got pictures, by the way, of them filling in stick trestles that were up to 100 feet high. And they continued, and by the time we got to the 1920s, instead of manually dumping them, you could get dump cars that used compressed air to dump them in. But anyways, that's how all the railways were built. So, so back to these locomotives. This particular one was then, when they were done in Illinois, it was sold to Kirkfield Quarries and Crushed Stone, which ends up being purchased by Dufferin Construction. And Kirkfield is just northeast of Peterborough. This little engine worked there from 1912 to 1958. And in 1962, they closed the quarry. So it almost had like over a 40-year working life. And so what it would do is they had a 2% grade in the quarry, so it would pull 6 cars down into the bottom of the quarry. They'd dynamite off the stone, and then they'd had a steam shovel down there, load 6 cars, and this little locomotive would pull the 6 cars up a 2% grade, spiraling up out of the quarry, and then take each car and push it up onto the crushing deck, where it was dumped into a steam-driven crushing plant where they crushed the stone, and then it would come out of a conveyor and dumped into hopper cars that were standard gauge, and then CP and CN would pick the cars full, and a lot of that stone was used as ballast stone, and that's how they got rid of the stone. So, because it was in a quarry for well over 40 years, every part that was wore on this thing that could be wore was wore out. So we stripped this thing right down to the bare frame, took it down to a company, and they shot blasted it all off, and then we brought in a testing company, and they used dye with dye penetrated to be able to make sure there were no tiny cracks in it, and they ultrasounded to make sure that it was solid and there was no problems with the frame. And then we started and we built it all back up again. The journals on this, the axles, supposed to be 4 5/8, they were all wore down, so we had to weld them up, and had to find a guy with a lathe big enough to be able to turn them down to the 4 5/8 dimension. We chrome plated the piston rods, and the piston and the cylinder were the only things that weren't worn on this thing. So we chrome plated them. It's got steam brakes on it, so where all the linkages pass through the frame, those holes were all oval shaped. So we put bushings in them. We had to machine up all the rods and linkages for the steam brakes. We had to go down and make a pattern, and we had to get cast new brake shoes. And so this locomotive will be superior to what it was when it came out of the factory in 1909. and better built. We had to replace some of the springs on this thing, and of course redo the piping, and we had to patch holes up in the tank, and then a lot of the fittings, like for the injectors and all that, and the piping and the connections into the tank, we made out of all stainless steel. Same with the handrails up there, that's all stainless steel, right? So this thing's built to run in perpetuity. It's going to be operating long after I'm gone. So if this thing had 40 years of service in its working life, this will go on into perpetuity because it's so well made, or will be so well made compared to what it was when it came out of the factory. Same with all the bearings and bushings. We had to rebuild all the crown brasses, redo all the bearings on it. And part of our museum, besides what you see out here, is our archival library, which we have over at the house. And that library over there, I can't go to anybody and ask them, oh, what is the clearance on those bearings? Because, you know, we've had like 5 generations since this equipment was used. So I depend on engineering books that have been written in 2 centuries ago in the early 1900s to give me the clearances and all that sort of technical information, because I can't ask anybody. So as an example how important that library is over there, I worked in the electrical industry for 50 years, and if we're doing a big shaft with a sleeve bearing on it, our rule of thumb for a big electric motor, like if you had a 5,000 horsepower motor, you maybe have a 5-inch shaft. The rule of thumb was the clearance you needed to get the oil between the bearing and the journal was 1 to 1.5 thousandths of an inch per inch of shaft diameter. So this is 4 5/8, so I would have had required to do maybe 5 thou, 6 thou at the most clearance, using my rule of thumb. And I thought, you know, I better check in these old-time books. So I had a book in the library, printed in the 1920s, How to Design a Locomotive. And the book was written by the chief engineer of Baldwin. So he knew what the hell he was talking about. So he starts the chapter on machining the crown brasses and the bearing boxes for a locomotive. And he starts the chapter out, he says, the minimum bearing clearance on a locomotive bearing shall be no less than 30 thousandths of an inch. 5 times what I was going to make it. Not only that, you're to put a 28-degree taper on the upper crown brass so the oil flows in and then gets squashed in to that 30 thousandth of a clearance gap in there. So if we would have went with what I would normally do, this thing would have went a half mile down the track and seized all up. So that's so important, that archival library out there to tell us what the hell we're doing. And I can tell you some other stories. That technology that was used to build steam equipment and all that is in like the engineering manuals that were printed around 1890s to maybe up till the Second World War. And then after that technology isn't used anymore, in later editions of the engineering manuals, they take that information out. So if you bought a new engineering manual printed in 1980, it wouldn't have that technology in it. So this is why it's so important to have those old-time books from over 100 years ago to tell you what the hell to do.
Hey, Wayne, can I ask? You didn't mention it. That's a whole brand new boiler.
Yes, it's a brand new boiler, all welded boiler that we put on.
All brand new, not a...
Brand new, made by Oliver's Boiler Works. So we didn't use the old riveted boiler because it was thinned out too much and warped, and you know, from all that lifetime of work. So we started out with a brand new all welded boiler, and originally when it came out of the factory, and in their catalog, when you buy this, you'd have kerosene lamp headlight, and you'd have a kerosene lamp in the cab. But we've chose to put a Pile National 32 volt DC generator on it, and there's a company down in the States that'll still supply you with all the parts to rebuild these. Because Pile National, that was the standard generator that every locomotive had up on the top to be able to run the headlight and the cab lighting, and maybe some of if there's the tender light for the cab, for the tender, and maybe the first car or two behind it. So we had to get a new turbine blade for that, because it's a steam turbine, is what it is. So we got that all rebuilt. We got a new headlight with it, with 32 volt lamps. In fact, we got a 120 volt lamp in there now. So just so you can see what it looks like. Is that nice and bright? So anyway, 32 volts will be the same. The reason they chose 32 volts in the railway industry and in the car lighting in the railway cars is that 32 volts, as you lower the voltage, the filament gets thicker, so that the click, click, click on the railway track, the vibration doesn't go up. If you had a 120 volt light bulb, the filament is thinner, so you fracture it. And on top of that, they put a rubber socket on it so that it'll absorb some of that vibration. So the standard in the industry was 32 volts DC, which we actually were able to get some 32 volt bulbs. Anybody got any questions about the rebuild on this?
On the piston shaft, you said that's chrome plated.
Yeah, we chrome plate them all.
Was that common diamond?
No.
I was saying
No.
machine steel.
It'll be just machine
So
steel.
that's when it went into the piston, where
Yeah.
a lot of heat can come back out where it could be cool if you're running this time of year.
Yeah.
No problem.
No.
Hot and cold, hot and cold.
No. When we rebuild all the traction engines, we do the same thing with chrome plate. All the piston rod and the valve rods, we chrome plate them all. Yeah.
It's not a big enough difference in temperature, Larry, when it comes in and out. You're really not getting much more than the general heat of steam
Yeah.
in your material.
I thought that might be kind of warm.
Yeah, and
Warm enough to burn your hand.
Exactly.
yeah, and the grates, we've got one of the volunteers out here is a retired pattern maker. So the grates were all worked on this thing. It was coal fired, so we got a shaking meter to rock the grates. So we had to go down to the foundry and get new grates cast for it. As I said, this will be better than when it came out of the factory. I don't know what else I can tell you about it, but
I like how you have the steam dome over there. You have it on the sides, and you can see the working parts inside the steam dome.
yeah, and so it's got two sand domes that go on it, and sand dome for the front and sand dome for the back, and apparently they did have to use those sand domes when they're quarrying in the wintertime, when they get ice on the rails and all that.
Even that ramp they had up into the crusher.
Yeah.
That's what steep ramp.
Yes.